realize is that probably just as many surfaces, both within the rooms and on the external walls, for example, of the courtyards and of the open areas, were finished. A great deal of that at Spruce Tree House survives because of the incredible preservation exists here because of the depth of the alcove. And I'm sure you noticed as you went into the alcove, you could see more and more preservation with entire rooms, which we didn't get into, are in fact finished. We, of course, need photographs. You cannot really do condition surveys on drawings. You need the image, and understand that the graphic is a way of exaggerating or articulating the condition that you can only see in a photograph visually. You have to give it some meaning. So we do it through symbology. Now, why do we do this? What does this mean? Who cares? Well, the point is, it will be a way for future conservators to monitor the decay mechanisms and also evaluate the treatments. Photomontage has been screened. The photograph has been screened. The montage has been screened back, and then all the conditions that we're recording, conditions are equal. Some conditions might be a prelude to other conditions. Some conditions might be the antecedents to another condition. So if we know how to actually look at these maps, they, what I call pathographies, they might actually be able to be used to predict future failure where it hasn't happened. Extent of finishes, extent of repairs, which are blue, and where the schemes, where we believe the schemes to exist, or where we believe the components to exist. So here you can see what I want you to see are the two dados. Here's the aura surviving, unfinished field. Up here, there's a floor band, a dado, and the traces of an aura, again when it was an exterior wall. And then you see all the blue are repairs. Those are patches. That second story room is in nearly perfect condition. So this is a map, this is a document of integrity. Integrity is a function of damage and repair. And so this wall has very little damage and very little repair. So its integrity is very high. So here's a case where we had a wall of very high integrity in terms of extent of finish, but very poor condition when you saw the other drawing. So that's why this scored very high in the list of rooms to treat. This was very, very important, high significance, high condition threat, high public access. Now, interesting, isn't it interesting? The upper story had a lot of surviving plaster and very little repair, but look at all the treatment that went on. Because the flakes were still attached, they weren't lost yet. But this could have become a situation of loss had we not gotten to it. On the treatments, it was voiced by most of the tribal affiliates that they would rather not see synthetic materials used in the site. So that sent us back to the lab to think about what other adhesives we might be able to use. And that, plus the unsatisfactory result with the acrylics, led us to one of the oldest adhesives known, which is gelatin. Gelatin's been used since the 18th century for easel paintings, for reattachment of flakes. And of course it was pushed out of use by synthetics, which were also water-based, but also were not biodegradable. A near-perfect adhesive in terms of the rheology. Think about it. You can use a material, one material, you can vary its percentage in terms of what kind of adhesion you need, and you can vary its state in terms of whether it's liquid warm or gel cold. So with one material, you can get changes in concentration and you can get changes in state. And that is an incredibly versatile material. It's very elegant, it's very simple, it's non-toxic, it's reversible. It really was, it was the perfect meeting of cultural and scientific requirements. This piece is loose, this piece is very loose. These are great candidates for grout. All we basically want to do is get some grout in there to tack them in place. Just make sure there's no blockage in there. It's also a good time to see how far deep it is and how much grout it might take. So you just want to, and when you're doing this, hold the piece in place. Normally you want to grout from the bottom up. So you're going against gravity, you're displacing air and filling the void with grout. So as you grout from the bottom, you should be seeing it rise to the top and come out the top, or at least see it. So what you can always do later is come back with a fill the color of this and then just do a little mortar fill with soil, so that, because the grout is a gray color. So the cotton takes the place, takes the space up to give you some room for pointing, if you will, or edging, as we call it, and the grout, of course, stops the grout from coming out. Now, okay, you don't want to put too much water in, but you do want to pre-wet. If this was a lime or cement masonry, you were grouting, be no problem. But because this is all earth-based, too much water, this whole thing will collapse. So you got to be really judicious with the water, and where you inject is going to get wetter and it's going to start to crumble, so you want to really try to get the water in, not on the surface. All right? Do some preliminary opening. And you always want to have cotton ready in case you have a spill out. You see it's wetting all along the crack here? Mm-hmm. See it? So that means it's connecting. The water also tells you where it's connected, okay? Between each syringe of grout, you should reshake it. Do keep your finger on this. This can pop off. They're high-speed mixed, but to avoid any potential for segregation of the solids from the liquid, you want to just give it a few minutes of a shake. Just hold this, tip it, and then fill it only half. So only fill about 10 to 15 cc's. Slowly. And when you pull it out, there should be no ball of material on the end. That's an indication that your grout is not well mixed. Always, you have another container of water. Always rinse, work clean, dry it, and be conscious of keeping the syringe up like this when you're not using it. Okay, so and then just test it to make sure you get the air out and make sure the grout is flowing. So, you see the grout has a fairly thixotropic consistency. It's fluid enough to inject. If this was an absorbent surface, it would have actually very little flow on it. Put the needle on. Okay, it's good. Okay, I'm going to put my syringe in, and I'm going to okay, see it's coming out there? That's good. You want it to come up from above, okay? So I'm going to leave that cotton there. And I'm now going to go out from that point.